Ice giants are a subclass of giant planets that differ from gas giants primarily in their composition. While gas giants like Jupiter and Saturn are composed mostly of hydrogen and helium, ice giants like Uranus and Neptune contain a significant amount of water, ammonia, and methane, which are referred to as ices in the planetary science context. Here's everything known about ice giants. Ice giants are composed of heavier elements than the hydrogen and helium-dominated gas giants. Uranus and Neptune, the two ice giants in the solar system, both possess deep atmospheres, layered interiors, and are known for their vibrant blue hues. Ice giants are smaller than gas giants, but still much larger than terrestrial planets. Uranus and Neptune have diameters of 50,724 kilometers, 31,518 miles, and 49,244 kilometers, 30,598 miles, respectively, making them about 4 times larger in diameter than Earth. Both Uranus and Neptune are approximately 15 to 17 times the mass of Earth, significantly less massive than Jupiter and Saturn. The density of ice giants is higher than that of gas giants due to the presence of heavier elements. Uranus has a density of 1.27 g/cm superscript 3, while Neptune is denser at 1.64 g/cm superscript 3. The defining feature of ice giants is their unique composition compared to gas giants. Hydrogen and helium. While these elements are still present in the atmospheres of ice giants, they make up a smaller portion of the planet compared to gas giants. Only about 20% of their mass is hydrogen and helium. The bulk of ice giants consists of elements that form ices: water, H2O, ammonia, NH3, and methane, CH4. These materials exist in solid or liquid forms deep within the planet due to the intense pressure. The presence of methane in the upper atmosphere of Uranus and Neptune absorbs red light, giving both planets their characteristic blue color. Ice giants have a different internal structure from gas giants. At the center of both Uranus and Neptune is thought to be a rocky or icy core made of silicates and metals. The core may be 1.2 to 1.5 times the mass of Earth. Surrounding the core is a mantle composed of water, ammonia, and methane, which are sometimes referred to as slushy ices. These materials likely exist in a fluid, supercritical state due to the extreme pressures and temperatures inside the planets. The outermost layers of ice giants are composed of hydrogen, helium, and methane. Unlike gas giants, ice giants have relatively thin atmospheres in comparison to their overall mass. The atmospheres of Uranus and Neptune show unique characteristics. Both planets have cloud systems composed of different compounds. The uppermost clouds are made of methane, but deeper clouds likely consist of hydrogen sulfide and ammonia. Winds on Neptune can reach speeds of up to 2,000 kilometers per hour, 1,200 miles per hour, making them some of the fastest in the solar system. Uranus also has strong winds, though they are less extreme. Uranus is colder than Neptune despite being closer to the Sun, with an average temperature around -224 degrees Celsius, -371 degrees Fahrenheit. Neptune, on the other hand, has an average temperature of -214 degrees Celsius, -353 degrees Fahrenheit, but its internal heat source generates more heat than it receives from the Sun. Both ice giants possess unusual magnetic fields. Unlike Earth, where the magnetic field is closely aligned with the rotational axis, the magnetic fields of Uranus and Neptune are tilted at extreme angles. Uranus' magnetic field is tilted by 59 degrees, and Neptune's by 47 degrees relative to their rotation axis. This tilt, along with the fact that their magnetic fields are offset from their centers, leads to complex and dynamic magnetospheres. The magnetic fields are likely generated by the motion of conductive fluids, possibly ionized water or ammonia, in the deep interiors of the planets. Ice giants rotate quickly, with days lasting around 17 hours for Uranus and 16 hours for Neptune. Uranus has a dramatic axial tilt of 98 degrees, meaning it rotates almost on its side. This extreme tilt results in unusual seasonal variations, with one hemisphere experiencing 42 years of sunlight followed by 42 years of darkness. Neptune, by contrast, has an axial tilt of 28 degrees, which is similar to Earth's tilt and results in more moderate seasonal changes. Ice giants have their own unique systems of moons and rings. Uranus has 27 known moons, the largest of which are Titania, Oberon, Umbriel, Ariel, and Miranda. These moons are a mix of rock and ice, with some showing evidence of geological activity in the past. Uranus has a set of 13 faint rings, which are much darker and thinner than Saturn's rings. These rings consist of small particles, likely made of ice and rock. Neptune has 14 known moons, the most notable being Triton, which is one of the largest moons in the solar system. Triton is unique because it orbits Neptune in the opposite direction of the planet's rotation, suggesting it was captured by Neptune's gravity. Triton has geysers that erupt nitrogen gas, indicating active geological processes. Neptune has a system of 5 faint rings that are primarily composed of dark material. These rings are relatively thin and incomplete, with some areas more densely packed than others, forming arcs. Ice giants formed in the outer regions of the solar system, but their exact formation process is still debated. Core accretion model. According to this theory, ice giants began as solid cores that formed from the accumulation of rock and ice. Once the core reached a certain size, it attracted a surrounding envelope of hydrogen, helium, and other gases, although it didn't attract as much gas as Jupiter and Saturn. Another possibility is that Neptune and Uranus formed through gravitational collapse from gas and dust in the protoplanetary disk. This process would have allowed the planets to form more rapidly, but they may have migrated from closer to the Sun to their current positions. Some models suggest that Uranus and Neptune formed later than Jupiter and Saturn, or that their formation was delayed by interactions with the gas giants or nearby planetesimals. Unlike Jupiter and Saturn, which emit more energy than they receive from the Sun, Uranus emits very little internal heat. This is puzzling because Neptune, despite being farther from the Sun, radiates more heat. The reason for Uranus' lack of internal heat is still not fully understood. Neptune radiates about 2.6 times more energy than it receives from the Sun, indicating a significant internal heat source. This may be due to slow contraction of the planet or heat left over from its formation. Only one spacecraft has visited the ice giants. Launched by NASA, Voyager 2 flew past Uranus in 1986 and Neptune in 1989, providing the first and only close-up images of these planets and their moons. No other missions have visited the ice giants, though there are proposals for future missions, particularly to study Uranus and its unique tilt. Ice giants are common in other planetary systems. Many of the exoplanets discovered are ice giants similar to Uranus and Neptune. These planets often exist at distances from their stars where temperatures are low enough for water and other volatiles to freeze into ices, similar to Uranus and Neptune. Some exoplanets classified as mini-Neptunes are smaller versions of ice giants and are one of the most common types of planets found in the Milky Way. Ice giants, Uranus, and Neptune are fascinating planets with distinctive compositions, extreme weather systems, and dynamic internal structures. They stand apart from gas giants with their higher concentrations of ices, unique magnetic fields, and strong winds. While they remain the least explored of the solar system's planets, they offer valuable insight into planetary formation, atmospheric dynamics, and the potential diversity of planets beyond our solar system.